So Friday, day 5, cardioids, and remember limacons, and it's not really a C, it's a C that has the little tail-looking thing on it. What does the first, 6 letters of cardioids? Cardio. Okay, you guys are smart people. What's cardio mean? What's the basic word that, what does that word mean? Heart. Right, so maybe in medical terminology or the medical stuff, cardio is heart. And the idea is, okay, it's a bit of a stretch maybe, but the cardioids look like hearts. I mean, I guess they look like hearts in the same way that roses look like roses, right? Like it's a stretch, but you can see where they got the name from. Especially this third one. That one looks like as close to a traditional looking heart as we would see. Some of these have different orientations and stuff. So cardioids are hearts. Limacons are a little bit tricky because some of the limacons don't have a loop, and some of the limacons do have a loop. And by a loop, I mean that little bitty inner loopy thing. It's called a loop. It's not a fancy word for it. So some have loops and some don't have loops. And so, you might think, oh, that's 2 separate categories of shapes. Like, well, not really. It's kind of the same category of shape. And we group them together because they have very similar equations. And maybe that makes sense because their graphs are really similar. In fact, you can see how we've sort of matched them up. Similar graphs, so very similar equations. In fact, we're going to do cardioids first, but cardioids in some ways are a specific case of a limacon. Like a circle is a special case of a rose, sort of. Like it's a one-petaled rose. Well, a cardioid is kind of a special case of a limacon. That'll make more sense once we do a limacon. Do you need to have all the equations memorized? You need to know what they all look like. Now, how much memorizing? Because the test will have some equations, given to you. We're not going to tell you what they are, but you can sort of use the test to help figure out the test, kind of a thing. So you need to be able to recognize them. We're not going to give them to you and tell you what they are, but neither are you going to have to come up with them completely on your own. Does that make sense? It's a multiple choice test. You're going to see equations that look like this. The answer to your question is no, we're not giving you the formulas. Put it that way. Cardioids. They both look like A plus B cosine or A plus B sine. Cardioids are heart-shaped. Cardio, heart. Always go through the origin. Make your cardioids nice and plump. Have a heart, a big heart. Have a big heart. First example. Sine goes with the y-axis. We've said that several days in a row now, or actually months in a row, right? Even all the way back to the unit circle. The sine of an angle is the y-coordinate. Sine goes with y. So you kind of get the basic shape of it. It's up and down. 2 plus 2 gets you how far out to go. Right? 2 plus 2 is 4. And the side units is the first number. I guess it doesn't matter because they're the same, but it'll matter for limacons. So 2 plus 2 gets you the furthest out. The first number gets you the side units, and then this point is always 2 minus 2, or the A minus B. Now, for a cardioid, it's always 0. That's what makes it a cardioid. So it's always going to go back to the pole. Let's do an example. I think that'll help most of all. 3 plus 3 sine theta. Okay, so we know we're on the cardioid, but 3 plus 3 sine, that's a cardioid look. Sine tells me it's on the y-axis. So I know it's going to be an up and down cardioid. So I know what it's going to look like already. 3 plus 3 is 6, so I'm going to go out 6. So there's the outermost point. So 3 plus 3 is 6. That first number is the sideways points. So 3 and 3 on either side. And 3 minus 3 is how far back it goes. So those are sort of my 4 key points. But this is why it says make them nice and plump, because it's tempting. Once you get those points, students are like, okay, I can draw a heart. Look at that. That's my heart. Like, well, that does look like a heart more so than the actual graph, but they're supposed to be more like circular. Like that. All right, which direction is the second one going to be going? Cosine is left and right, or it'll be on the x-axis. But it's negative, so it's flipped. So already I know what this is going to look like. It's going to have a left-right orientation, but it's sort of going to be pointed to the left because of that negative cosine. So how far out should we go? How far out is this point?
2.
Well, the farthest out point, we add the 2 together. Don't worry about the minus sign. We use the minus sign to flip it over. So 2 plus 2 is 4, so we got to go out to 4. The sideways points, so 2 plus 2 is 4. And then that first number gives us the sideways points, so up and down 2. Yeah, they're not really sideways, I guess, because the orientation has changed. And then 2 minus 2 is 0, back at the origin. So we'll flip it over. Try that. Try this one on your own, although I'll tell you that the negative 4, the first negative 4, doesn't matter. You might remember that r equals 4 and r equals negative 4 are the same graph. It's kind of like that here. This negative doesn't matter. This negative flips it over. So see if you can sketch that one. Think about its orientation. Think about where the 4 plus 4 goes, and think about where the 4s go. Sine is flipped. It's on the y-axis. Well, no, sine is y-axis. Negative is flipped. 4 plus 4 tells me how far out to go. 8. The first number tells me how far to go on the sides. And then 4 minus 4 puts it in the middle. And again, that's only 4 points. It looks like a T, but you know what the shape looks like, so you need to draw it. very rounded heart. All right, that last one is kind of the backwards problem. R equals. Is that last one a sine or a cosine cardioid? Cosine. Remember, this number out here is a plus b. So 6, what two numbers? Yes, 3 and 3. It's positive because it's pointing to the right. And it's sort of confirmed by the 3's on the sides. A little note here. Notice that the number in front of theta must be 1 to be a cardioid. If the theta coefficient is not 1, you get a different graph altogether. And so here's it looks like a rose. It's not really a rose. We don't have a name for this. We're not going to graph these. But if you're playing in the calculator, you can get all sorts of fun and crazy graphs. All right, limacons. Okay, so the equation looks like a cardioid equation, except that A doesn't equal B. If A equals B, then you're back to a cardioid. If A and B aren't the same, then you have a limacon. Now, we already saw the picture. Some don't have loops, some do have loops. Here's how I remember how to know which one is which. If you have R equals 7, that's a circle, right? And so this lead number, the A number, is the number that's trying to make it like a circle, right? If you didn't have B stuff there, you'd have a circle. The B number is trying to make it loopy. And so if the circle number is bigger than the loopy number, then it's more like a circle and it's no loop. If the loopy number is bigger than the circle number, then like the loopy number takes over and you get a loop. To me, that's easier to remember than, who's A and who's B and greater than and less than. Like, just R equals A is a circle. So that A is the one that's trying to make it a circle. B is the one that's trying to make it a loop. And so they're having this fight, and if A is bigger than B, then it's more circular. So that would be this example right here. Without a loop, if the circle number is bigger than the loopy number, then it's more circular. On the next page, the loopy number is bigger than the circle number, so it has a loop in there. Some of the cardioid stuff still applies. So you add the two numbers to get to the outermost point. So 3 plus 2 is 5. That first number gives you the sideways points. And then you subtract the numbers to get the dimple, I think it's called. Right? Because it doesn't get sucked all the way into the pole. That would make it a cardioid. Let's do some of these. Again, a quick sketch to the side is almost more helpful. So what's its orientation? Left, right, or up and down? Yeah, up and down, because it's Y. It's negative. The sine part's negative, so I know it's going to be down. And the circle part is bigger than the loopy part. So it doesn't have a loop. It's a circle. All right, so how far out do we need to go? How far out do we go? 6, because we add the two together. So 1, 2, 3, 4, 5, 6. So 4 plus 2 is the farthest out. The 4 is the sideways parts. 1, 2, 3, 4. 1, 2, 3, 4. So that just where we put those. And then the top point is 4 minus 2. So 2. Again, you only have 4 points, but you know the basic shape of this thing. Again, try to make it very round. It's not a game of connect the dots. Three plus cosine. So I know it has an x orientation. So it's going to look like that because the circle piece is bigger than the loopy piece and it has an x orientation. So how far out is the farthest point? 3 plus 1. 1, 2, 3, 4. How about the side points? How far out are they? Careful. 3 plus 1 gets me the farthest point. 3 gets me the sideways points. 1, 2, 3. 1, 2, 3. The sides of the heart. And then how far back is the indentation? 2. 3 minus 1. And again, it's only 4 points, but you know the basic shape of what's going on. Again, what flips them is whether the sine or cosine is negative, not that lead 5. So you can, this is going to graph the same as if that was a positive 5. Same thing. So see if you can graph those next two. And like how dimpled it is, like the further out the dimple, the less pronounced the dimple, I guess. So like this first one we did was a little closer in, and so it has a little more pronounced dimple. You can see the ones on the picture. Some of them hardly have a dimple at all if they're a little bit further out. So don't feel like you have to make it look like a heart. And then this last one, cosine, so it has an x orientation. 5 plus 4 is 9. 5 minus 4 is 1. Maybe we should have done the plus and the minus first. So 5 plus 4 gets you the farthest out. 5 minus 4 gets you the closest in. And then 5 on the sides. Ugh, that's not the best picture. Okay, move into the other way where you have to get the equation. Let's pick on some people. You guys are getting quiet on me. Kyle Schmidt. Is that a cosine or a sine limacon? How do you know it was cosine? Because it's left and right, so we know it's cosine. Okay, now we got to start thinking. We already said the farthest out is a plus b. The one in is a minus b. But what's probably easier is the sideways points, because that's the first number. So maybe we start with the sideways points. So that's 3 out. So that's the first number. And then if we want let's see, we need a plus b to be 5, a minus b to be 1. So, Charlotte, what number needs to go in front of cosine so that 3 plus this number gets me to 5?
3.
Well, this is at 5.
Oh, okay, so it'd be 2.
So it'd be 2. So 3 plus 2 gets me to 5. 3 minus 2 would get me to 1. So it's kind of a double check on everything matching up. Caitlin, on number 2, is it sine or cosine? Definitely sine. Maria, it's like it's upside down. It's pointing down. What is that? Why is it pointing down? What would make that happen? A negative. And a negative on the sign, not on the first number. So I know it's negative.
How would we tell if there was a negative on the first?
You wouldn't. Remember, the graphs would look the same. So that lead number, and it could have had it happened on this one. If you made that negative 3, it'd be the same graph. Okay, I think the sideways numbers are the easiest ones to get. So, Emma, put your glasses on.
5.
And I think that goes out to 5 on the sides. Which means, Olivia, I think this is 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. But what does that mean this number needs to be? 3. So 5 plus 3 would get us to 8. We could check the other one. 5 minus 3 better be 2. And it is. So we're good with the 5 and the 3. Tori, that next one's kind of tricky to tell, maybe. Is that a cosine one or a sine one? I think it is a cosine one. Kyle, I feel like it's pointing the wrong way. Right? It's pointing to the left. So what does that mean? What? It means it's a minus cosine one. Keegan, how about the first number? What's this first number going to be?
4.
Good, 4. The sideways points are 4. Andrew, what's this second number going to be?
1.
Let's see, because 4 plus 1 would get us to 5, and 4 minus 1 would get us to 3. Well done. We'll skip the last one just in the interest of time. Here's another goofy graph that we won't have to do. Right? So it's like, it's part circle, it's part loop, but it also has a 5 in there, so that's like a rose. And so it's like a combination of all the things. We're not going to do that kind of graph. That's kind of crazy. All right, limacons with a loop. It's still the same kind of thing. So let's just start graphing this one. All right, 1 plus 3. All right, so it's sine, so it's up and down. It's loopy because the loopy part's bigger than the circle part. So I need a loopy part there. But some of the same rules apply. Like the furthest out point is still 1 plus 3. And the sideways points are still the first number. And the loopy part is still the difference of the two, 3 minus 1. Except instead of doing 3 minus 1 and getting 2 on the back side, we're going to do 3 minus 1 and get 2 on the inside, and that's where the loop will come in. Okay, these are kind of tricky to graph. They also always go through the pole somewhere. So the pole is always also one of your points. So it's like, how do I connect all these dots? Well, it takes some practice. But once you know loop or no loop, the process is the same. Add the two numbers to get the farthest point, take the first number to get the sideways points, and subtract the two numbers to get the opposite point. In this case, it's a loop. Okay, so number 2. Let's see. How do I know? Well, we're in the loop section, but 2 is bigger than 1. The loopy part's bigger than the non-loopy part. Let's see. Cosine puts it in the x direction. It's negative, though, so I know it's pointing to the left, and it has a loop. One plus 2 will get me the far point. 1 minus 2 will get me the inside point. And that first number will get me the sideways points. Again, make them loopy, make them circular. It's not a game of connect the dots. Try to make them as circular as you can. Ugh, even that one's not great. All right, you try the next one. So, sine means it's up and down. Negative means it's down. The farthest point's 2 plus 5. The inner point is 5 minus 2. And the sideways points are 2. And we always include the origin. So for me, graphing them, I start at the origin and then try to do a really loopy graph. Oh, I missed that point there. My graph looked good, but I missed the point. Let's skip the last one and see if we can come up with equations for these. So, Kristen, on that first one where we have to name the equation, is it a sine limacon or a cosine limacon? How did you know it was cosine? Right. How did Haven know it was cosine? Because it's on the x-axis. Anything with a left and right orientation is cosine. So I know it's going to have a cosine in there. Let's see. Ty, what else do we know? I'll just leave it very open-ended. Tell me something else about that graph. Which way is it pointing? Is it pointing sort of normal or backwards?
Negative.
Good, so negative. And then the easy points are the sideways points because that's always the first number. So Megan, what's that first number going to be? 2. And then the second number, Julia, what's this? Let's see, we got to get out to 7. So yeah, that needs to be a 5. And then we could have the double check. The inside number should be 3. 5 minus 2 is 3. So yes, we're good. Second one. Crystal. Sine or cosine? Sine, because it's up and down. Alina, is it a positive sign or negative sign? Positive. Good. Perfect. I got 2 popsicle sticks left and 2 questions left to ask. Oh, Haven, you already answered one, so you can answer this one for yourself rather than for someone else. What number is going to go here?
2.
How did you know that?
I put it on the side. Oh yeah, the side ones.
The side ones, yep. The side points is that number. Jamil, how about what number goes here? Well, could you refer to the ones that you've not been doing? Okay. This is what happens when you don't watch. This makes it really difficult. We need these two numbers have to add to be this. 1, 2, 3, 4, 5, 6. So now what number needs to go there? 4. And then there's some more crazy graphs that we don't have to worry about. Oh, there's one more person that I didn't call on. A couple of you that don't have popsicle sticks I need to check on.
That's okay.
Ryan and Landon are like hiding. On the back of this, I'm going to say there's only 2 shapes you need to know. Roses. A sine or cosine of n theta. The special case if n equals 1, what does this graph become if n is 1? A circle. It's one petal, so it's a circle. For a limacon, this is what we just did. A plus b sine or cosine of theta. And the special case is if A equals B, what do we call that? That's the one that goes back to the pole. That's a cardioid. So do you have to memorize the equations? Yes. But there's kind of only 2 equations. And then some special cases just sort of happen out of that if certain things happen. Yeah, we still got to be careful about number of petals. A plus B is the far point. A minus B is the opposite point, I guess you could call it. And I mean, there's more to it than that, but trying to simplify it so it doesn't feel like there's 4 completely separate things going on. There's 2 things going on. Roses that have a special case, limacons that have a special case. Now, the good news is we're done learning new stuff. Again, Monday's lesson really isn't that hard. Tuesday is review. Wednesday we'll test. So if it still feels a little bit weird, that's okay. There's more time to get caught up. All right, this was day 5. So worksheet 5 is the assignment.